Hi, my name is Andy and I'd like to show you a project that I've been working on here, which is a wood-fired geyser heater. Essentially a tank system over here with a furnace in the center, which is used to heat the water that runs through a standard domestic geyser. It's a geyser that is typically used for solar panel applications, but I'm running the water from the heater through the solar panel circuit in the geyser. It has a circulating pump over here, which does the water routing, but it also can be used to route the water from the geyser through a car radiator there, which I use for cooling the water down after a test. So right now, the temperature in the geyser from the last test is 30 degrees, and that's where we're starting. Okay, so now I'm going to demonstrate how we light the fire in the geyser. And the first thing I need to do is to take out the wood magazine, which fits inside here, and we fill it with some chunky firewood, like this. Right, so now the cylinder is full of these sticks and that have been chopped up, and it contains about 1.3 kilograms to 1.4 kilograms of wood. We now need to add a handful of smaller kindling wood just to get the fire started, a little piece of fire lighter, about a cubic centimeter or a little bit more to start the fire, and a little bit of charcoal, which helps to eliminate smoking during the early stages when the furnace is getting going. Finishing off, we've put a little bit of wood shavings just to add something for the fire to burn, and light the fire lighter. Okay, so now we can put that into the furnace, which is sitting inside the water heater, and lock it into place, the bayonet clip. The furnace is situated in this part of the geyser, which is where the main combustion takes place, and it takes about 5 minutes from what I've just done here to lighting it before we'll start seeing some indication of a temperature rise at the exit of the furnace, and then we will start the process of heating the water as we show. There's a slight trace of smoke as the kindling is catching, and if we have a look at the temperature, you can see the temperature in the stack is now starting to rise 42 degrees and climbing. So now that the temperature is hotter than the water, I can now turn on the circulating pump. So now the flue temperature 68 degrees and rising slowly, and at this point now there is no trace of smoke. We're about 4 minutes into the burn. So now we've reached 100 degrees in the flue, and the fire is completely on its burn. The smoking has completely stopped because all the smoke is being combusted with the secondary air because of the gasifying principle on which this is based. And if you come down to the base here where the air enters the furnace, you can actually hear the roar of the fire. So now we're getting close to the maximum temperature of the flue, only 110 degrees centigrade. The reason being is that the heat exchanger is taking the heat from 1,000 degrees in the furnace to approximately 100 degrees at the flue, and I'll demonstrate how cold the flue is by putting my hand on it. So this is the flue, and as you can see, I can put my hand on it, and it's hot to the touch, but not burning my hand. And that's as hot as it will get. The fire has now burned through the wood pile and has reached the bottom, and we're left with a pile of charcoal, which is now having a secondary form of combustion, where the charcoal is burning from the air supply at the bottom of the fire and continuing to provide heat for the geyser. At this stage there is no smoke coming out of the stack either, because the charcoal burns without smoke. We're about 30 minutes into the burn. We've reached the end of the gasification phase. The temperature will remain high as the charcoal burns, and we'll have about another 10 minutes before the charcoal is all burnt out and the burn is over. So there we go. The flue temperature is now 49 degrees and I've turned off the circulating pump. The geyser temperature, as a result of burning 1.3 kilograms of wood, is now a healthy 53 degrees. And if one does the calculation, the thermal efficiency, in other words, the energy in the wood to energy in the water, calculates out at 90%.